Hello everybody and welcome to today's lesson on basic trig functions and finding angles. Our objectives for today are we will be able to show the relationship between angles and sides of a right triangle using the sine, cosine and tangent ratios, and we will also be able to use the inverse trig ratios to solve for unknown angles in right triangles. Trigonometry is the study of the relationship between the sides and angles of triangles. The three trigonometric ratios that we use the most are called sine, cosine, and tangent. And we abbreviate all three of them using the first three letters of each word. But even if we see the abbreviations, we still call it by their full names: sine, cosine, and tangent. So this first ratio here to the left is the sine of B, and B is always an angle, and it's actually one of the acute angles of a right triangle. We don't use it for the right angle. We use it for one of the acute angles. The sine of the angle B is the ratio of the length of the opposite side over the length of the hypotenuse. The cosine of angle B is the length of the adjacent side over the length of the hypotenuse. And the tangent of angle B is the length of the opposite side over the length of the adjacent side. And remember, adjacent means next to. The adjacent side is the side that's next to, that's touching the angle we're talking about. There's a great mnemonic or memory trick that you can use to remember all these ratios way better, and it's called SOH CAH TOA. SOH CAH TOA. And SOH CAH TOA stands for the sine is the ratio of the opposite side over the hypotenuse. The cosine is the ratio of the adjacent side over the hypotenuse, and the tangent is the ratio of the opposite side over the adjacent side. So CAH TOA, even better, it can be written the way we see here on the right, where it also shows that we have to build the ratios between the two respective sides for each one of these three functions. Then let's go and try practicing some of these trig ratios. In our example, for the right triangle DEF, we're supposed to write the trig ratios using both the side names and the lengths. So let's find the three ratios in relation to angle D. So we are basing everything off angle D right here. And let's first start identifying the three different sides in relation to angle D. The easiest one being the hypotenuse. Remember, we got a right angle here, and we can imagine the right angle symbol being like an arrow pointing towards the hypotenuse. So this one, which is also always the longest side of a right triangle, is our hypotenuse. And that, by the way, will also never change for the same triangle, irrespective of which angle you're looking at. Now let's look for the opposite side. The side that does not touch the angle D at all is across from it, opposite. This is what we call the opposite side. And that leaves us with a third side, and we see that the third side here also touches angle D. That is our adjacent side. Let's write down our mnemonic SOH CAH TOA so we get to remember it better. We will be doing that at every problem because SOH CAH TOA is very important. We want to really memorize it as soon as we can. And by the way, SOH CAH TOA is something that will stay with you in math all the way up to pre-calc or even beyond. SOH CAH TOA. SOH CAH TOA stands for the sine of an angle is the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. And the tangent of an angle is the opposite side over the adjacent side. Okay, first we're supposed to do it using the side names. So the sine of angle D is the opposite. In other words, EF over the hypotenuse, which is DF. The cosine is the adjacent side of the hypotenuse, so that would be DE over DF. And the tangent is the opposite, which is EF over the adjacent, which is DE. And we do know their lengths, so we can and we're supposed to also show the ratios of the lengths. The sine of angle D is EF, which has a length of 3, over DF, which has a length of 5, so 3 over 5. The cosine of angle D is DE, which is 4, over the hypotenuse, which is again 5. And the tangent of D is the opposite side, in other words, 3 over the adjacent, which is 4. And here we have our ratios, both in terms of side names as well as the given lengths. Or if you like, you can also circle it in the colors that we used before. Yellow for the side names and orange for the lengths. There are a couple of things that I want you to remember and really note down very well. The opposite and adjacent side depends on which angle we are looking from, right? Not every angle is adjacent to the same side or opposite to the same side, so we have to really look, depending on which angle we're supposed to find these ratios for, which is that angle's specific and unique opposite and adjacent side. The hypotenuse doesn't change, we said that before. The other two sides do change depending on the angle. And the other thing, and we also have mentioned that before, we only look from acute angles, never from the right angle. Now let's do the same thing, find the ratios, but this time in relation to angle F. And the first thing we're going to do again is we're going to write down our SOH CAH TOA. And this time, because I do like it that way, I'm going to write it down showing that we have 3 ratios of fractions that we're really dealing with here. And again, the sine of angle F is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse. And the tangent is the opposite side over the adjacent side. And since we're now talking about angle F, even though it's the same triangle, before we talked about angle D, we will get different answers. So let's first identify our sides and take it from there. This is our angle F, and we can start with the hypotenuse first because the hypotenuse doesn't change. Our right angle is right here and it's pointing towards this side. So this is our hypotenuse. But this time, if we look at the side which is opposite of angle F and doesn't touch it, that's actually down here, the side DE. and then our adjacent side will be the one that touches angle F right here on the side. This is our adjacent side. Then the sine of angle F is the opposite side over the hypotenuse. Remember that. And in this case, this would be side DE over DF. And if we use the length of a side, it is 4 over 5. Why don't you stop the video at this point and try to find the cosine and the tangent of angle F yourselves, and then compare your work with my answers. Hopefully you came up with the same answers. The cosine of angle F is the adjacent side over the hypotenuse, in this case EF over DF, and that is equal to 3/5. And the tangent of F is the opposite side over the adjacent side, in this case DE over EF, and the ratio is 4/3. These are our answers in terms of numbers. In our next example, we're supposed to write the trig ratios in relation to angle A, and we're supposed to write them in exact simplified form and then round it to 4 decimal places. Now the very first thing we are going to do is we're going to write down our SOH CAH TOA. SOH CAH TOA. And next we are going to look at our angle A, and we're going to identify which sides are the adjacent, the opposite, and the hypotenuse. Starting with the hypotenuse, as it's the easiest one, this is the hypotenuse, the side which is across from the right angle. The opposite side from angle A is the one that doesn't touch it, that has the angles B and C on it. And the adjacent side then is the one that does touch angle A, and the remaining side here anyway. Adjacent. Okay, the sine of A is the opposite side over the hypotenuse. The opposite side has a length of 2 square roots of 3, and the hypotenuse has a length of the square root of 21. We are supposed to do two things. We're supposed to show the exact answer fully simplified, and then afterwards the rounded answer. Now, the fully simplified answer can never have a square root, a radical in its denominator, so we need to get rid of that. And in order to do that, let's first see if there's stuff we can simplify under the radicals. And to do that, I'm going to use one of the radical properties, and I'm going to make this the radical of 3 over 21, because then I see that I can simplify this fraction. 3 goes into 21 7 times and into itself once, of course. So now we really have no more radical in the numerator. We have just 2 over the square root of 7. 2 over the square root of 7, but that's the thing we can't have. We can't have a square root in the denominator, and in order to rationalize the denominator, you remember that from Algebra 1, we need to multiply this by a fraction that has the square root of 7 in both numerator and denominator, because now we're going to get 2 times the square root of 7 over, and the square root of 7 times the square root of 7 is, of course, 7, and that gets rid of our radical. We are also supposed to give the answer rounded to 4 decimal places, and in order to do that, we're going to use our handy-dandy calculator. 2 times the square root of 7, and the square root you find above the x squared symbol. You get it pushing the blue second button first. Then we need to move out from underneath that radical, and that whole thing gets divided by 7. And the answer is 0.7559. The number next after the 9 is a 2, so we round down, not up. Very good. So, and since this is an approximated answer, we're going to use the squiggly equal sign, 0.7559, rounded to 4 decimal places. Now let's find the cosine of angle A, which is the adjacent side over the hypotenuse. The adjacent side has a length of 3, the hypotenuse square root of 21, and again we need to simplify, which means we need to get rid of a radical in the denominator. Multiply this by the square root of 21 over the square root of 21. We get 3 times the square root of 21 over 21, because the square root of 21 times itself is of course 21. And now we can even simplify some more. 3 goes into 21 7 times, into itself once of course. So we get 1 square root of 21 over 7. We are also supposed to show the rounded answer here. So I'm going to use my calculator again and punch in the square root of 21 divided by 7, and that is 0.6546, and after the 6 we got a 5, so the last 6 needs to be rounded up. So our rounded answer is 0.6547. Let's not forget to circle all our good answers here. And then move on to the last one. The tangent of A is the opposite side over the adjacent side. The opposite side is 2 times the square root of 3 over 3. And here we cannot simplify, or don't have to simplify anything, because there is nothing we can do with the numbers outside of the radical, and there's no radical in the denominator. This is our fully simplified answer, and I did this on the calculator just like the 2 times before. Our rounded answer is 1.1547. Go ahead and use your calculators to find that answer yourselves, to practice using those steps on the calculator. Alright, so much for this, and now go ahead and watch the second part of this video.